Hi, welcome back.
So having a variable for the exponent creates what we call an exponential equation. And this is very different from a quadratic or even from a linear equation. So a linear equation is something like this. And let's say this is modeling my height, and I grow 2 inches every year, right? So every year we add 2 inches to our height. But what an exponential model does is that it just skyrockets. So instead of, let's say, adding 2 inches every year, I'm actually multiplying by 2 inches every year, or multiplying my total height by 2 each year. So you could imagine, well, if I'm 1 foot tall, then next year I'm 2 feet tall, and then I'm 4 feet, and then I'm 8, 16, 32, 64, 128, 256. Notice how quickly these numbers spike up compared to 2 plus 4, 6, 8, 10, 12, 14, 16. You get the idea. So let's do an example with Alice in Wonderland. So in Alice in Wonderland, she ends up encountering cookies that say "Eat me" and a little drink that says "Drink me." Now every time she does the "Drink me," she shrinks because it rhymes. Drink, shrink. Every time she doesn't "Eat me," she ends up growing. What's in that "Eat me"?
Hello there.
That's for you to find out. Let's say her regular height is 120 centimeters because the entire world uses metric except for 3 countries. One of those happens to be America.
Hi, welcome back.
So,
Certainly glad you could join us
let's
today.
start off with the first case of eat me. So if she eats something, she ends up growing. And every time she takes one bite from an eat me, her height is doubled. So it's not like we're going to add 2 more centimeters. We're actually doubling her height. So here's one bite. She's originally 120 centimeters, but if she takes one bite, that's double. So one bite means I'm going to multiply that her original height by 2. And that gives me 240 centimeters. Simple enough. I mean, that makes sense, right? You just double your height. Great. What if she takes 2 bites instead? So let's go back to the original problem. She's 120 centimeters tall. She takes 2 bites. Every time she takes a bite, it's doubling her height. So that's 1, 2. That's like quadrupling because she took the 2 bites. So that's 480 centimeters. That's quite the growth. What if she had 3 bites instead? So again, we're going back to the original problem. She's 120 centimeters tall. But if she takes 3 bites, each of those bites is double, double, double. Now, if you don't get the picture yet, we can express this as 2 to the third power, right? So that's 2 to the third power, which is 8. This was 2 to the second power, which is 4. This is 2 to the 1 power, which is just 2, right? 120 times 2. So notice a pattern here that it's because she doubles. Each bite is a double. So for example, what if she took 20 bites? Well, that's going to be 2 to the 20th power, right? 3 bites, third power. 2 bites, 2 power. So anywho, we'll come back to that in a bit. That's 120 times 8. That's 960 centimeters. That's quite a bit. Like we're talking about
Life
yeah, that's quite a bit.
finds a way.
All because of 3 little bites. So what if we play the eat me game, but instead of her doubling this time, she's tripling? So again, her original height is 120 centimeters. She takes one bite, boom, triple the height, 360. Great. Well, what if she takes 2 bites instead? So her original height is 120. Each bite ends up tripling. How many 3's do we have? That's just 2. So I could write this as 3 squared. But what's 3 squared? 9. 120 times 9. That's quite the growth right there. See, she didn't even get that tall in part A with 2 bites, or 3 bites. Here she's just doing 2 bites, but that's because her growth rate is tripling whereas in part A, it was only doubling. What if she took 3 bites? Well, her original height is 120. That's 1, 2, 3. That's 3 to the third power, which is 27. 3,240 centimeters. Wow. Part C. So what if, okay, so let's go back to the case where she has an eat me cookie that doubles her. What if she took 9 bites? Now you're thinking this is pretty ridiculous. Well, it's fantasy, right? But that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 2 to the ninth power. What's 2 to the ninth power? 512. So what we're trying to do here is show you that there are better ways than to write 2's all day long. Because if I ask you, how tall will she be if she, eats 400 bites, you're not gonna write 2 400 times. Hopefully, I'm hoping that you'd catch on to the idea that there is an exponent here, right? So here, before we had 2 to the first, 2 to the second, 2 to the third. If you look at part A, part C, we have 2 to the ninth, right? If I wanted 17 bytes, it would be 2 to the 17th power. So what I'm proposing to you is, in order to come up with a faster way to do this, it's always been 120, right? That's what you start with. The birth rate or the growth rate is going to be whatever the eat me cookie is, right? Is it a double? Is it a triple? Is it a quadruple? Is it a 2/3? Okay, so it's a double, in this case a growth. So I'll put a 2 in here, and then x is going to be the exponent. In this case, so this is like quote unquote the formula for any eat me cookie that doubles Alice's height. And all I need to know, so instead of writing all these 2's all day long, okay, all I need to know is how many bites did she take, the number of times that she bit the cookie. Now, of course, we change this, right? If she happens to be buying a cookie that's tripling, like in this above one, part B, then this would be the formula for like part B. So notice that we have to modify the situation based on what's going on, right? What if Alice's bigger sister comes along and starts eating this same eat me cookie that triples her? And what if Alice's sister happens to be 160 centimeters instead? Well, then we would change that number. So there's a lot of what ifs, okay? But for this specific problem that we're dealing with right now, the situation is Alice is 120 centimeters, and it's in this part C, it's doubling. So I'm going to put a 2 right there. And you just tell me how many bites Alice took, and I can tell you how tall she got really fast by putting this in a calculator. Okay? Those were the eat me cookies. Now, about the drink me. If she takes a sip of drink me, then her height in this case is reduced by half. So now she's shrinking. She's getting smaller. You hopefully are catching on to the pattern here. Her original height is 120. She takes 1 sip. That's half her height. That's going to give me 60 centimeters. If she does 2 sips instead, okay, so here's her original height. That's 1/2 and 1/2. But again, notice a pattern, right? How many 1/2s is that? That's 1/2 squared. Which, if you distribute your 2, that's a 1 and that's a 4. Ah, snap, 1/4. So anywho, 120 times 1/4, that's 30. This is making sense because we are shrinking, right? We're halving the number each time. So if she's 120 originally, what's half of 120? 60. What's half of 60? 30. What's half of 30? 15. So let's look at, what if she had 3 sips of drink me instead? Well, that's 1/2, 1/2, 1/2. Where does 1/8 come from? Well, 1/2 to the third power. 15 centimeters. So we could, of course, we could do this all day long, right? We could half all day long. But we need a better and faster way to do this. What's her original height? She's not growing this time. She's actually shrinking. So instead of a 2 for doubling or a 3 for tripling, she's halving each time. So I'm going to put a half in here. And then, just like before, this is an exponential. The variable is the exponent. And so what this allows me to do with this problem is you tell me how many bites she took, and I can tell you how how tall she is after all the shrinking, right? So you want 17 bites, great. You could do this all day long. You could do 120 divided by 60 divided by 30 divided by 15 divided by, 7.5, etc., until you get to some crazy decimals. Or you could just say, hey, plug in the 17 number in here, pop in a calculator, done. Quite lovely. How would this change? Well, what if she was drinking Drink Me? She took a sip of Drink Me, and it instead of did a 1/3 on her. Well, then you would change it to a 1/3, right? Okay. Or if her height were different, you would change this number. So again, the same ideas as before. Just notice the patterns. And the big takeaway with both part C and part E is that the variable is the exponent. And in this case, it represents the number of times she either ate something or she drank something. For part C and E, explain how this basic form was used to model both situations and any similarities and differences that you notice between both situations and the results.